receive range. And what differentiates different SDRs from each other is going to be like how much can you listen to at once within that range, how good of a receiver is it, and can it transmit or not, that kind of stuff. I'm really disappointed. Yeah, okay, so this is a good picture, right? This is an SDR. This is a weird SDR, but it's an SDR. Actually, it's a RTL SDR, so that's cool. Another thing I'm going to talk about is this SIG-ID wiki. They're awesome. They do a lot of work to help you when you're out there scanning the airwaves with your SDR dongle. They have pictures of what most things you'll find look like on the waterfall, and we'll talk about the waterfall in a second, and then sound samples. And we'll come back to this. But let's get started. Let's turn on an SDR. I don't know if sound's going to come through. I kind of hope not. So what we're going to do, actually, before I do this, I've configured my SDR. This is SDR++, by the way. Great open source SDR tool. Very cross-platform. Supports a lot of SDRs. So I'm going to, up here, you just say, hey, I have this kind of SDR. You pick which one it is. These settings, the defaults are usually pretty good. Sometimes you might need to turn up whatever gain your SDR has. Mine's going to be different from yours, but we'll talk about like what are good models later. And then we hit play. This is broadcast FM. So like if you're in your car, you're listening to like 98.7 The Rock or whatever, right? This is what that is. You're looking at what it looks like over time. This thing that's kind of falling down. We call it the waterfall. And then also kind of a live plot of signal strength up at the top above where it says FM broadcast. And congrats, this is SDR, right? We can change the frequency up here. We can tune around a little bit. We can find some more stations. And again, I hope audio isn't working. Okay, it's not. But if you could hear things, you would be listening to 96.3, whatever music they're playing, right? Now we know, because it's FM radio, right? We know that what modulation we need to set the SDR to is going to be this wide FM. Radio comes in a lot of different, or RF, there's a lot of different ways to encode data in RF. We've got FM, which is frequency modulation. We've got AM, which is amplitude modulation. Don't ask me to explain the difference. I'm not qualified to talk about it. Look it up. I will quickly talk about the difference between AM and, you see this USB, LSB, DSB. Let me see if I can find a handy picture for it. AM has this nice little, here we are, that's what I was looking for. Shout out to Wikipedia. Right. So AM has this carrier signal in the middle. Let's go look at, we have the power. Let's go find an AM signal, right? I don't know, actually, but we can figure it out. This is the other cool thing I like about SDR++, is it'll show you sort of band plans and that kind of thing. Band plans being where things belong in the spectrum.
What happens if you press the AM button on the little radio tab with WFM and...
It just sounds weird.
Oh.
This is...
If you listen to AM, it'll be decoding an AM broadcast.
Yeah.
If it's an FM broadcast and you try to decode it as AM, it sounds really funky.
Yeah. So you always want to try and match the modulation to what it is, because it'll sound... You want it to sound correct, right? You want to be able to... Or if it's not audio, if it's text, you want to be able to pull the text out.
Yeah.
That kind of stuff. Does anybody know a good AM station in Salt Lake? I literally
1160.
never... 1160, thank you.
Yep.
Oh, you know what? This is outside of the range of the filter on this SDR. So we're going to do FM after all. But it'll be a good way to point this out anyway. So you see in this signal here, click into the middle of it, this red line when you're doing FM, you want it to line up with what we're going to talk about here, this carrier, right? This strong signal down the middle, and then you've got stuff on the side. And so with AM, same thing. You've got this carrier down the middle, and then you've got the lower sideband and the upper sideband, and that's where your audio is encoded. So when you come over here and see USB, LSB, DSB, that means instead of AM, let's cut out the carrier and the sideband. Again, I'm not really qualified to talk about this. Look it up if you need help. But really, what you can do, let's say we wanted to listen to, I don't know. Also, you won't only find FM signals in like the broadcast FM band. Most walkie-talkies will use FM. Business radios use FM. Honestly, a lot of stuff
I
does.
thought they used a different band specifically for like.
Yeah, so they'll be on a different frequency, but they're still using FM modulation.
Oh, it's the modulation.
Right.
Yeah. Another
part of SDRs is going to be your antenna. This is going to be a thing to talk about. You can get like general kind of receive antennas across a wide range. I'm a big fan of the disc cone. They look funky. There's stuff like this, like
expanding it, you can change the tuning.
Yeah, things like Jared has here, right? Like you said, you can pull it out and kind of change the frequency that the antenna is resonant on. When it comes to receiving only, which is mostly what you're going to be doing with an SDR, then the length will matter less, but the lower you go in the spectrum, it still helps to have a longer antenna. Any questions so far? Anything that hasn't been clear? I know this is an alpha class, right?
Did you say what program you're using to display
This is SDR++. It's open source. The maintainer, super great. He has a Discord. You can ask him questions. He helped me figure out a bug. I couldn't get it to launch on my computer for whatever reason, and he helped me through it. Really great guy. I think his name's RiseEarth, something like that. Some other things we can do here. We can zoom in if we want to see the signal really, really bigly. You can also play with these settings here on the side will change kind of the range of what the waterfall looks like. And so you want to kind of keep it within this plot up here. And
So is that the sensitivity?
it's not the sensitivity, it's how the waterfall is showing things. The sensitivity, you would turn up gain over here.
Okay.
Also, for those of you who are fancy enough to have cars with HD radio, let me see. Let's try this. There we go. You see these flat, bars on the side of the FM signal. That's HD radio. For those of you that are curious, another thing you can do here in.
But they go into different, like.
So HD radio is digital. It's decoded a different way, but they put it on each side of the FM signal. You can also.
I'm more confused because that's 89.1's frequency, and then if I were to tune in to 88.9 or.
Yeah. The way the HD radio works is it just keys off of the center frequency. So it'll still say if you're listening to that 88.9, it'll still say you're listening to 89.1.
Yeah, it'll say 89.1 HD2 or whatever.
They're not spaced that close together, so it's not going to be stepping on top of somebody else.
Yeah, it doesn't step on anyone either.
That's all I was wondering.
So now that we've seen this, let's push this SDR a little bit and let's expand our range. This SDR I have will do a little bit more range, and so we can see more signals at once, which I really like. So you can see. I wish there was an auto button for this. Here's an FM station with HD radio on each side. Here's another station that doesn't have HD radio.
Okay, I can see the lack of overlap much more now.
Yeah, they're intentionally coordinated so that they don't blast through other signals, other things, right? The FCC handles all of this. If you are going to transmit RF, either you have a device that's already licensed or you need to get a license and you need to learn the rules. If you're just receiving, it's not illegal to listen. It's illegal to transmit without a license. This is SDR. Any questions before I start talking about SDR models and that kind of thing?
Are fractals antenna in scopes? Specifically, are they frequency specific, or could you get a little tiny fractal antenna and use it instead of something huge?
I actually know nothing about fractal antennas.
So the SDR will pick up whatever your antenna picks up and interpret it. If you have a bad antenna, you will get bad everything on your SDR.
Sorry, thank you for that. Let me repeat that for the people in Discord in case they couldn't hear. Basically, your antenna is your ears, right? If you have a bad antenna, the SDR is going to pick up only what that antenna can hear. If you have a good antenna, you'll hear more, sometimes too much, but we can talk about that in another class. Speaking of frequencies, if you want to find out where, let's say you wanted to listen to business radio, maybe you want to listen to the local the bacon plant, coordinate how much bacon they're gonna make this today or whatever, right? So the first thing upon Googling is going to be this chart. I don't recommend this chart because it's terrifying and it's far too detailed. There's this awesome website.
That's not even from the FCC. That's the Department of Commerce.
It's from I think it's from NTIA, isn't it?
It said
I don't know.
Department of Commerce.
The FCC is under the Department.
Surprising with that detail, it still doesn't have a bacon plant.
No, there's a bacon plant off the freeway that has their own radio frequency.
Yep.
So radio reference is going to be the place you want to go to find things most of the time. So if I Google radio reference, it is radio reference, right?
Yeah.
Okay. Yeah.
Yeah, you just go to databases
Database.
at the top there.
There we go. I've never gone to their website. Okay. This is the radio reference I know and love. So let's say we wanted to listen to the police back in Logan, where I live. Okay, I guess not.
You have to type in Logan instead of.
Oh, okay. There we go. So Cache County. And you get a handy little map and a table of here's
Cache County
Cache County Jail. Here's the Senior Citizen Center bus. Here's
the Tactical Police State.
One of my favorite ones that I've listened to is the Utah State system. The shuttle buses have a frequency that you can listen to, and it's not encrypted, and so you can listen to the bus drivers talk about how great certain bus models are. I'm not kidding. It's great. It is absolutely riveting. I loved it. I listened to it for 2 hours. I didn't expect to, but it was a lot of fun.
Give me your SDR. I want to
How was
listen to this
catering?
now.
Did you listen to catering?
I haven't listened to catering. The problem is most of the time when I feel like playing with an SDR is it's too late and most people aren't out and awake and doing things.
Ogden.
Yeah, let's look at Ogden. Sure. Oh, come on. Don't do this to me. Okay. Ogden's going to be a lot, probably. Wow. Okay. Guess not. Joke's on me.
Ogden.
Yeah.
One thing to note specifically for Utah is that most government and government adjacent things are going to go through what's called the Utah Communications Authority, where it's a statewide, giant, huge trunked DMR network. DMR is a type of digital voice encoding that lets you do a lot of cool stuff. And so we're talking, they have towers and systems everywhere in Utah. There's not billions, but there's hundreds of groups that use the UCA system now. Most places have migrated to it. But also, shout out to the people who update and keep this updated so you can find what you're looking for without struggling too much. So if we wanted to find Ogden...
So is the UCA good or bad for listening with SDR?
It depends on who you ask, and...
But is it easier or harder to listen because of it?
Harder, and sometimes you'll need more than one SDR. The other thing that comes along with this is in a lot of other states, these systems will end up being encrypted, so you don't get to listen at all because you don't have the encryption keys. I don't believe UCA is, or at least most of it, but I haven't gotten my SDRs to work enough to listen to it. The best trunking software out there doesn't support my SDR yet, but it should in the next month or two, so I'm excited. It'll be a lot of fun. I want to set up like a live broadcast. You know when you go online and you're like, oh, I want to listen to the police radio, and it's on like Broadcastify or whatever. People take this data, set up an SDR, and then just decode it and stream it to the internet, and that's what that is. So yeah, here's Ogden. You could...
Special training tactical.
Animal control. Strike Force.
Ogden water. Zero water.
Yeah, water, sewer, sanitation.
Water.
They've got separate talk groups. Wow. Oh, you know what? Okay, so here's the thing. We got A, and then we got E. I'm pretty sure E is encrypted.
Of course the strike force is encrypted.
Yeah,
you
so
don't want to
you'll-
know when the drug busts are happening.
Oftentimes you'll see like there will be like a police tactical channel that's encrypted. That's not uncommon. I can't find another
The
one.
tactical channel wasn't.
But
The special force.
well, yeah. So
Strike
like it
channel
depends
was.
on your local radio system. Like look at radio reference because I'm not the expert. I'm not. I don't know how many times I have to say this. I'm not qualified to talk about this stuff. I'm just a guy that messes around with it. So this is radio reference. And it's really cool. Another cool thing that I'm going to attempt to do a live demo of is what's called ADSB. And that is most planes over a certain size are required to have a little transponder that sends out little signals that says, hey, I'm here, I'm at this location, I'm this high, I'm this plane, and here's some other like telemetry data.
So that's where all those maps come from.
So if you've seen Flight Aware or whatever,
X mode.
I actually really like ADSB Exchange. ADSB Exchange is cool because they don't censor anything. Like they will show you where Elon Musk's plane is. They will show you where Air Force One is on the map. And so this is who I feed my ADSB to. Where's...
That's New York.
Yeah, there used to be like a... Is there not a location button to... It's cool.
Yeah,
I'll figure it
there
out.
is.
Where?
Search, jump to airport latitude or latitude longitude next to the.
Oh yeah, let's do Salt Lake City. That'll work. So here's Salt Lake City. The color of the planes tells you. So this is Salt Lake City. If you couldn't tell by all
A little
the.
more.
It tells you the altitude.
Yep.
Yeah. So like if we look at this plane, this is a SkyWest plane. This high, and it's being picked up by 5 receivers in Salt Lake right now. That's pretty good.
Zoom down, go down to that.
So it looks like right now Salt Lake is doing their land from the north traffic banner.
Exactly. You can get. What is,
They
who's
just
this?
took off.
Who's this? Let's find out. A stratotanker, a military plane. That's the other fun thing about ADSB Exchange. But we can see some of the planes on the ground that
military plane.
are powered up, right? You can even see little planes, little guys, that came out of.
Airport number 2 usually has planes coming in and out.
Where'd he go?
That one.
So he came from like Spanish Fork-ish. Um,
Zoom in right there. Go down a little.
yeah.
Up.
Wait.
He wants to zoom in on base.
Oh yeah. Airport number 2, right?
Airport number 2 is 78 South,
Oh okay.
but I don't know if there's anything coming or going from there right now.
Yeah. Anyway, so this is a live view of all the planes. And we are going to see how much of this we can pick up with an antenna that has been conveniently placed on the roof.
Oh yeah, we have that, don't we?
And we're going to get more. One thing that's kind of precipitated all this SDR stuff, all this radio stuff, is I worked with an organization to get us a little bit of a grant. So we're going to get a whole ham radio set up. We're going to get a permanent ADSB set up here. We're going to do satellite ground station stuff, which should be really cool. Lots of stuff coming. Lots more ADSB specific classes coming. We're going to build an antenna. Everybody's going to show up. We're going to have parts. We're going to build some ADSB antennas.
You want me to bring some people who did military stuff?
Absolutely.
Who did all
Could-
the military radio?
Yes.
Side note,
Yes.
could those built antennas be used for Wi-Fi too?
Because I'm trying to-
I want to make an extremely excessive Wi-Fi antenna.
You can build your own Wi-Fi antenna, and I'll talk to you after the class. I have some recommendations for you. No, I don't need to update my SDR software. This is another piece of SDR software. Actually, you know what? Let's quickly talk about this. There are the biggest, kind of cheapest SDR you're going to find out there is the RTL SDR. It looks like a little USB stick with an antenna connection on the end. I just want the picture. Okay. You plug in your antenna on the connector thing, and you plug it into your computer, and it pretty much just works. I think with SDR++, you don't need a driver even. You just plug it in, run the program, and you're good to go. Clipper asked a question about, can you recommend some good bacon plant frequencies? I'm pretty sure Jared found the bacon plant on Radio Reference earlier. Like, I wasn't kidding. That's a real example. Sorry I missed your question, but yeah, it's again with antennas.
Well, no, you already
Yeah.
went through it. Yeah.
For receive, it matters less, but for transmit, you'll have it tuned. You'll have it like a certain size for the frequency that you're trying to radiate on. But yeah, so these are RTL SDRs. They're like $35. You can find them in a lot of different. Oh, this is a great picture. This is a good example of this. A lot of different form factors, ranging from absolutely tiny to. These blue plastic cases are very popular. Like if you wanted to buy a really cheap one, this is pretty common for this. It'll come with a little antenna thing. I assume the remote is for if you're using this to actually receive TV, which nobody actually does, especially in the US. These RTL SDRs were originally a TV tuner chip for...
Siri, stop.
Go away, Siri.
Okay.
Thank you. No, that's...
Okay.
All right. Thank you. RTL SDR started out as a TV tuner chip that people realized just sent all the RF data to the computer and made the computer do the work, and then they said, hey, wait a second, we can use this everywhere. We can use this on a wide range of frequencies. So the cheaper ones will have slightly less tuning range. They might not be able to send quite as much to the computer at once for you to see on the waterfall. So how I expanded it out, they won't be able to expand quite as much. The other one I'll quickly talk about, and this is what we're going to use at the workshop, is there's this company called SDR Play. They make really good receive SDRs. But their first version was sort of kind of mostly just a reference design based on the chips. Most of them look like this. I have the RSP2. It has some more ports on it. The RSP1, they basically just took a reference design and built a box around it and sold it. And it's great. These are like 100. The RSP1A, I think, right now is on sale for 100. Super good receiver. Very wide range. I love mine. It's very good. But some enterprising Chinese ham radio enthusiasts figured out how to make a board like this, which is the same chips, completely software compatible with the SDR Play genuine RSP1s. There's some funkiness where they'll have different ports, or like this model has, you have to change the dip switches depending on where you're tuning for filters so that it doesn't get overwhelmed, but they're $10. You can get them from AliExpress for $10 to $11.
That one says 20.
Yeah. The cheapest ones I've found have been $11, and we ordered a bunch of them, and hopefully they come in time for our workshop. If not, I'll do the workshop here at the space.
What's going on with the one with like the 5 antenna connectors? Is that like correlating signal from multiple antennas?
I wish. That would be really cool. So each port gets a certain frequency range. You can almost... Ooh, I lost where I was. You can almost see it on this picture. There's a little bit of text here that'll say 50 to 120 megahertz or 400 to 1,000 megahertz. And what they're doing is bandpass filtering. So like, if you don't want to get overwhelmed by the FM broadcast band that's roughly 100 megahertz, they build these filters that filter out everything except the range you want to be in. The genuine RSPs will switch that in software, so you never have to really think about it. The RTL SDRs, I don't think have almost any filtering.
So you have one antenna plugged in this, and actually physically, like, you can't screw it into that one. Okay.
Yeah, but for a tenth of the price, sometimes it's worth it. And if you're setting it up as like a fixed thing where you're gonna do like the UCA scanning, if you were gonna just scan in the UCA system and listen to that, all of that fits within one port. So you just set it up for that one port and leave it and don't touch it, and that's okay. But for ease of use, the genuines are not too pricey, and they're very good. The other thing is the RTL SDR is like the community favorite. Almost every piece of SDR software is going to support the RTL SDR. Not nearly as many. I would say probably 30% of SDR software out there is going to support the SDR, the RSP one, the SDR Play. These like Chinese clones. Most of the like general receive stuff, like SDR Play, will work. This is SDR Play's, SDR++. This is SDR Play's software that goes with their things. It's a little weird. I don't like it as much as SDR++. But in this one specific instance, we're going to use it for ADSB, and it's going to be lots of fun. I started it on the wrong SDR. Sorry, I've got one of those RSP1 clones and the my RSP2 plugged in at the same time, so I started it on the wrong one. No. SDR Uno has an ADSB plugin, but if you wanted to set this up with SDR++, or you wanted to set it up on like a Raspberry Pi to do this ADSB stuff, there's images out there. There's tons of like pre-built Docker Compose stuff. Like there's a billion ways to get started with ADSB. I just like this because it's easy with the GUI. So we load the plugin, we hit start, and then we hit start again. And so immediately we're starting to see, here's one plane with a latitude and a longitude and a speed and a heading. And again, this is just from I think this is the 2 meter
Check your signal.
antenna on the... Sorry?
No.
Okay. This is just like a ham radio antenna we have on the roof that's not even built for ADSB. It's not meant to be used for ADSB, but again, like when you're receiving, it doesn't matter quite as much, and certainly good enough to get started. And then also, now that we've done that, if it starts, it wasn't starting earlier. Oh no. Anyways, there's another piece of software called Virtual Radar that'll pull up a very similar looking map to the one that ADSB Exchange has, where you can see the planes you're seeing on a map and that kind of stuff. There's also TAR 190. There's like a million apps for this. Again, this isn't going to be an ADSB class, but it's pretty cool. I really like this. I feel like this is an easy thing to get started. If you wanted to build kind of an SDR project that was persistent, this is a fun way to do it. And then if you want to do like general receive, scanning around kind of stuff that's not trunking, then I think SDR++ is probably the way to go.
Do you need something as big as what's on the roof to pick this up?
No, ADSB is up at almost right at the 1 gigahertz mark. There's a couple out there. You can buy some that are pre-built online, but they can be pretty short for ADSB. None of these really give a good example of the size. Like these are decent pre-built ADSB antennas you can use. That cheap kit I showed you earlier with the blue plastic RTL SDR, if you snip it at the right size, then it's a good ADS-B antenna, and that's a great way to like get started for cheap, right? And you can even go as far as this guy. Nope, other one. Who has hooked up 4? Where is it? Hardware. 4 RSP1s all at once to do all kinds of cool ADS-B stuff from a single antenna. There's a lot of cool setups. I recommend this Discord, the ADS-B Exchange Discord. Lots of cool resources. There's the I mentioned earlier the SDR++ Discord. Guys, super helpful. Lots of stuff to. There's a lot of. You can ask questions here. They have channels for different ranges of frequencies that you can ask questions in, or that kind of stuff. I talked about the signal identification wiki earlier. Same thing. So, yeah, you can come in here and you can say, oh, like I know my SDR++ says I'm in the airband range, but I don't know what this signal is that I see. And you can just scroll through here on SIG-ID Wiki. I'm going to zoom in and see like, oh, my signal looks like that, or it looks like this, and it sounds like, oh, that's AM. Great. And they've got sound samples, and they've got like frequency ranges of where it would normally be and that kind of stuff. I'm always going to plug this wiki. It's great. And then they have a Discord as well. So if you still can't figure it out and you go to the Discord and you take a sound recording and you take a screenshot of it and post it, 90% of the time someone would be like, oh, that's this obscure mode that the Russians use on Tuesdays. It's magic. They're so good at it. Just a wonderful resource. Questions, things you want to know, things you want to like try.
So it sounds like a sound recording is kind of the equivalent of a packet capture for this.
Sure. Yeah, like if you you can also in just about any SDR app, sort of general receive app like SDR++, which I'm going to start again. Come on. There will be an option to either record the audio based on like the modulation that you've picked, or you can also record the baseband, which is the RF data that's coming from the SDR. And so you could probably send them either, and they would be able to figure it out. Definitely a baseband capture would be more of the equivalent of a PCAP. An audio would be more like a PCAP with like a filter, or like you're only capturing like HTTPS traffic or whatever.
But for identification, audio is preferred?
If you have the modulation right. It just depends. Any other questions? Anything you want to like try or listen to? This is a...
If I wanted to like roleplay Jodie Foster from Contact, is there like an amateur radio astronomer scene around SDR?
Yes. I know there's the people doing like there's a lot of like radio astronomy stuff online. You can do there's a whole category. This RTL SDR blog, I like them a lot. They post a lot of cool like radio stuff, just general, usually focused on SDRs, but sometimes it's ham radio. Sometimes it's like, this guy figured out how to hack Tesla charging ports with his flipper. You know, that kind of stuff. But you can, if you Google around, like, yeah, there's totally stuff for this. I'm pretty sure what the frequency range that most people are using for radio astronomy is within the range of the RTL SDR. So it shouldn't be too hard to get into. It's not something that I've done personally, but it is very cool. You can also, I'll also plug this. This is one thing I want to set up here at the space. This is called SatNogs. And it's an open source worldwide network of satellite ground stations that are automated. And so when I was at Utah State, I helped work on a CubeSat about this big that went into space and died pretty quickly, but we won't talk about that. And one of the things we did is we worked with SatNogs, and we said, hey, we would love to use your ground station network and contribute a ground station of our own. And they said, sweet, that's awesome. If you send us a description of what your packets look like, your telemetry packets, we'll make this really cool dashboard that pulls all the data from every ground station that's decoded stuff from your satellite around the world and turn it into, put it in this Grafana dashboard. And so if we look for the last 2 years-ish, so live, while the satellite was up there, we didn't have to rely on it being over us to downlink telemetry and data. We got to see battery voltages and stuff live while it was, just this range. There we go. So like this is part of when it was in orbit, going around the Earth, in and out of the sun, right? Temps would go up while you're in the sun, temps would go way down when you're out of the sun, that kind of stuff. SatNogs is just such a cool project. SatNogs map. And Utah has an unfortunately low amount of receivers, and I would like to have more. And so we're going to put one in. Hopefully USU still has theirs. Good. But as you can see, like, the U.S. needs more, but around the world, things are looking pretty good, unless you're Russian. The other, and so like if we go look for, I don't know why I'm looking at this screen. I can look at my own screen. You can download, this is another thing that I have some friends that are really into this, is you can pull down data from weather satellites, from like NOAA or that kind of thing that are up in, oh, sorry. I'm looking at pending observations. So if we look at good observations for a NOAA satellite. But anyways, you can pull down like weather images from, what did I do wrong here? Oh. It's been a while. But anyways, so these images that the weather satellites send down, so this is, SatNogs will do a cool thing where it records a picture of the waterfall, it'll record audio of the waterfall, and it'll automatically decode the images. This person doesn't have as great of a receiver for these images, but you can pull down...
slow scan TV?
This is APT, which is similar. Okay. It's a little bit higher resolution, same idea. And it's right below the ham bands too, so like if you have like a Yagi that's built for ham satellites, you can easily use it for this stuff. There's also the GOES satellites, which will provide more detailed data, and if you'll give me a second, I'm going to find has link. There it is. I'm pretty sure it's this one. Yeah, so my friend has a thing where they automatically pull down pictures and then show them on this cool dashboard. So if we wanted to look at this satellite picture that shows jet streams and turbulence and water in the troposphere, this is what we get. And they're just doing this with like a satellite dish on top of their house pointed at the sky, pointed at the right spot, because those don't move as much. They don't orbit around. And so like you can get some really cool pictures. They've gotten some really cool pictures of the West Coast that I really enjoyed. I wish I could find them. But like there's a lot of cool stuff that you can pull down from satellites with an SDR, with the right antenna. It's really cool. There's a lot of really neat stuff you can do with it.
So if it's entirely being processed on your computer, does that mean that the antenna is always listening to the entire band and you're grabbing a section of it? Or are you telling it to telling the antenna to grab a specific slice? So the antenna, all it's doing is RF that's in the air is generating an electrical current at the end of it. But your intuition is correct, but instead of antenna, it's the SDR. The SDR is always listening, is always picking up those electrical signals in its entire range.
but the chips in the SDR can only send you so much baseband data at once. And so that TV tuner chip in the RTL SDR only does like 2.4 megahertz by default, I think. The RSP ones will do like 10. And so that's where kind of you picking what you're listening to and how wide that stuff is within the band that your SDR supports.
So if I wanted to listen to Wi-Fi 6E, I'd need something that was 200 megahertz wide or something like that.
Yeah, more or less, yeah. And SDRs do exist for that, and they are horrifically expensive. Like this one I was looking at earlier. I want to show you guys how cool this looks. This is one that the V6X. This is one that the SDR++ dev is working on integrating into SDR++, and he posted some screenshots that I'll show you in a second that really kind of get across how wide the signal is on this thing. But it's about €5,000, but it'll do 10 megahertz to 6 gigahertz. It'll do transmit. It'll do 245 megahertz of signal via 2 USB 3 cables connected to your computer. He can see. So let's go look at it, right? I think it was here in dev. Sorry, it's like I said, I'm unprepared. Spectrum. They said they would send one, and they did, and it's cool. This one. The range on this, right? Like he's seeing from 0 to 240 megahertz, right? This is all of, like, FM and AM are like tiny little blips. Okay, this is FM. AM's down here. You've got like all of the airband stuff. This is like, if you've got a ham radio, you've got like one of those Baofengs. The entire range of at least the 2 meter side of the Baofeng is all this.
That's crazy.
But my favorite screenshot, and I hope I can find it, is this one. Yeah, I love this picture because, let's make it big. Not like that. He can pull out cell signals. Part of this is like cell phone stuff, and you can just see all of it. Or like you said, he could pull out Wi-Fi 6, that kind of stuff, like 160 megahertz, no problem. So the technology exists. It's whether can you afford it, right? RTL SDRs are really like the Toyota Corolla of SDRs, if you will. They're cheap, they're solid, they work, ish. And so that's what most people go with. Also because, like, that was really what got a lot of people into it, because it was cheap. It was an easy way to get started before, like, SDR Play started making their SDRs and that kind of stuff. So most of the software, again, will support it. Most of, like, if you have issues with it, like, there will be a community to help you out. And so if you're just getting started, that's probably what I'd recommend. If you want to upgrade, or you only want to pay $11 and you want to take a chance, like I did, my RSP1 clone has blown me away with how decent it is, even with the lack of software support. So,
are there specific? So that one's got a huge range, but are there specific things where this is only really good for like 5.01 to 5.02?
Yeah. I think I had seen somewhere that people made a Wi-Fi chip into like an SDR, sort of, and so it was only good within the Wi-Fi band. There's also there's this project, fully open source SDR Pi Hat, and they have one model that's just for ISM stuff. Somewhere. But look, it's got SDR++ support, right? Yeah, so they've got the ISM only module that's good in the like 2.4 gigahertz range, and then like the ISM stuff in like 900 megahertz and that kind of stuff. Also, I hate these tables. Like, if you are going to look at an SDR, you're looking at like the Lime SDR or whatever on Crowd Supply. These tables are terrible. Don't look at them. or at least take them with a large grain of salt.
The SDR that I use for plane tracking has a filter and a preamp, so it only works on about 1090.
ADSB exchange. So if you want to do just ADSB, they sell an RTL SDR, which is the one he's talking about.
I use flight radar SDRs.
Okay. But probably the same idea, right?
Yeah, the flight radar ones are cheaper usually than that, and they work really, really well.
Okay. Yeah, so these ones have filters that are specifically are only for ADSB, so it doesn't get as overwhelmed with other stuff. I think it's got an amp built in to kind of amplify the signal that's coming through your antenna. There's a lot of tricks. You can buy like a low noise amplifier and stick it by your antenna. So if you have like a long coax run down to your basement where you have the SDR, you can kind of amplify it up a little bit so you have less issues with loss in your coax and that kind of stuff. Yeah.
What was the name of that iPad you just showed?
It's called the Caribou, I think. Caribou Lights. If you go to Crowd Supply, they do a lot of like cool SDR projects. They have an SDR category. Lime SDR is a big, like if you wanted to step up your SDR game and not pay too much, Lime SDRs are super good, super cool, unless you're doing HF stuff, but you'll know if you're doing HF stuff. The Kraken SDR was a cool project. It's basically, they put 5 SDRs in a box, gave them the same reference clock, and so you can do passive radar, you can do direction finding for radio signals and that kind of stuff. There's a lot of cool stuff people have done with the Kraken.
They pulled a bunch of code this last week.
They got in trouble for passive radar because of silly reasons. There's Git mirrors of it. You could find it if you looked hard enough.
Is that like they're using multiple antennas to build like an interferometer? Or like triangulate?
Yeah.
Something to try. Okay.
Yeah.
That's cool.
And so that's like why you want to have them all have the same reference clock.
Yeah.
That's why you wouldn't just plug 5 SDRs in and do it from there. I actually have a friend who's going to try and do something similar with those RSP1 clones. Kind of take them out of the case and solder the clock pins together, and hopefully that works out. I think that would be really cool. But there's a lot of SDR projects on here. Like this Xtrax one, this is an M.2 card, right? Like this is tiny. This will fit in your laptop and do transmit and receive, if I remember right. But it's also pretty expensive. So yeah, Crowd Supply is a good website for some of those things. You can also just Google around. Another popular one is the Hack RF, and you can also find Chinese clones of it, but they're not always as great. The Hack RF is also sort of kind of an upgraded RTL SDR. It'll do 20 megahertz, I believe, and it has a wider range. And you can transmit with it, but you can't receive at the same time. It won't do like full duplex. You're either transmitting or receiving, and it's not like you transmit and then you can listen. It's your software puts it in transmit mode, and you're going to want to listen to something else.
So you need 2 if you're going to actually talk.
Or one in an RTL SDR or that kind of thing. But I've heard good things. I don't have one myself. The one
small cheap one from Great Scott called the Yardstick that'll do the same thing.
That's just transmit, right?
It does some receive.
Okay. Yeah, the Yardstick is interesting. It's got like a weird range on it.
Yeah.
There's also for the Hack RF, it's worth mentioning that there are these things called porta-packs, where basically you stick a battery and a screen and some smarts onto the Hack RF, and then you can walk around and capture, for instance, Honda car key fobs. And there's a vulnerability specifically in the Honda ones from like 2008 to 2022, I'm pretty sure, where you can predict what the next unlock code is going to be, even though they tried to do a rolling code. And so you can take one of these, listen to it, push the button, and it'll do the work, and then transmit it. Once you've heard one, then you can unlock the car yourself. Someday I'm going to do that to my car. Unfortunately, I own a Honda. But there's a lot of cool stuff with this. The porta packs are like flippers on steroids, basically, and only for RF. I think that about wraps up my class. I'm happy to stick around and answer more questions. Let me plug some cool resources. Like I said, SIG-ID Wiki, Radio Reference. I help run a Discord for, if you're into ham radio, I run a Discord for younger people in ham radio because it's traditionally a hobby filled with older white men. And that's all I'm going to say about that. It's called YARC, Young Amateurs Radio Club, discord.gg/YARC. I'm wearing my YARC shirt. I think it's a great resource. It gets a little goofy in there sometimes, but great resources. If you have like antenna questions, if you have, hey, I want a recommendation on a SDR or a ham radio or whatever, we've got channels for that. Great people in there to help out with that. And then I mentioned the SIG-ID Discord as well. Also, just like DM me. I love radio stuff. Just send me a message and be like, cleeb, I want to do this. I want to learn about this. I want a class about this taught at the Hackerspace, or I want to build an ADS-B antenna or whatever. A lot of the reason I've been focusing on ADS-B is because there's a ton of people already in the 801 Labs community that are really into it and that know a lot, and know a lot more than me, really, about it. Yeah, but this has been the talk. Sorry you guys had to put up with like alpha quality, me literally looking at Wikipedia in the middle of the talk, but thanks for coming.
You improv well.
Thank you.